Hey, hello everyone. Welcome to come back. In this section, I would like to give you a little bit introduction about our time arrangement. As I mentioned to before, I have already prepared 10 lessons here. So in these 10 lessons, we start with lesson 1 introduction. And the second lesson is LED control, and also third lesson is LED display. Lesson 4 is interruption introduction. Lesson 5 is push button application. Lesson 6 analog to digital convert application. Lesson 7 is LCD control. Lesson 8 is step and DC motor control. Lesson 9 is serial port based communication application. And lesson 10 is EEPROM application. I think if you are first time to involve in the microcontroller application, probably back to the physical board by introducing your actually electrical component. You should have a more clear understanding about those 10 lessons. I think I have already introduced you guys. This is the power supply port, power supply switch, and here are 8 LED diodes. So in our first lesson we are going to learn how to control those 8 LED diodes. And just on the right hand side there are 1, 2, 3, 4, 5, 6 LED tube indicators. I think this is a very common component to be applied in the industrial field, as we can say a lot of pressure or temperature, current, voltage, frequency indications are based on this kind of things. LED tube, or it has 1, 2, 3, 4, 5, 6, 7, 8 sections or 8 segments. So I think in lesson 3 we are going to involve in the introduction of how to use those LED tubes. And here is the setting pins to connect with LCD indicator. We are going to involve in the LCD application as well in lesson 7, I think. And there are 2 variable resistors. This one is for the brightness adjustment of 1602 LCD indicator, and this one is for the same purpose but for the different LCD indicator. This external communication leg is used for 12864 LCD indicators. So alright, after that, this is the communication port. All our program downloading based on this port. And we have 3 latches here. In lesson 1, when we introduction the LED diode application, and in lesson 6 when we introduction the analog to digital conversion test, I will show you how can we apply those 3 latches. This one is a oscillator. So this oscillator is 12 megahertz. This oscillator is used for the communication purpose, or used for this port. And we have a buzzer here, so basically just give you sound. I call it bell, but here we have a digital temperature sensor. This one is a little bit funny because basically it's just a transistor. So this experiment board try to use a linear relationship between the temperature and the current of the transistor. IB, I think it's called IB or IC. So to detect the temperature. I did this test before, but unfortunately it's not quite accurate, and also the linear region is not very good. Probably as long as the temperature out of 10 degrees and up to 40 something degrees, the indication or the actual temperature indication just inaccurate. Alright, this is a reset button, and just beside the reset button we have another oscillator. This oscillator is a little funny because its frequency is 11.05 to 0592 megahertz. I will tell you why we use such strange oscillator here. That's for some calculation purpose. So, but however, I'm going to tell you details about why later on. Okay, so this is our microcontroller, and the microcontroller has its external legs as well. That just give us a convenience when we would like to connect with the external components. So that's the microcontroller. Here, this one is the digital to analog converter, and this one is analog to digital converter. So when we work on the DA/LAD conversion test, we're going to apply those two chips. And here is a variable resistor, and this variable resistor is used for the analog to digital conversion test as well, because by adjusting this variable resistor we're going to adjust the input analog signal, and then we're going to pass that signal into the analog to digital converter, and to convert the analog input signal into a digital, I think it's 8 bits digital signal, and eventually that 8 bits digital signal will be as the output of this chip to be transmitted into the microcontroller, and the microcontroller will process based on the information received from that AD converter, and the microcontroller will does the relevant logic calculations. Alright, so that's the AD and the DA converter. Here it's obviously the press button, and one of the most common input component. So we're going to introduce the here you can say it's called keyboard or push button or whatever you call it. So we're going to introduce the application of the push button as well. Here is the serial port. As I mentioned before in lesson 9, the communication application, we're going to use this serial port to connect with either our laptop or some other electrical devices, and to achieve the communication purpose. I just did the interesting test about 1 month ago, so I tried to connect barcode scanner, connect with this serial port, and based on the barcode or the output of the barcode scanner, and the serial port will transmit that information back to the microcontroller, and then microcontroller can do the relevant internal logic, and then give me the output. So that's for the communication purpose. This serial port. Here you can say, sorry, not this one. This one here you can say it's a very small chip, and this chip is EEPROM, and this EEPROM has, I think, 256 byte memory. The reason why we need to apply the EEPROM is because when we working on some experiment would like, we can have a piece of memory to record the variable status. So in that situation, we need the EEPROM to save the relevant variable information. So, and that EEPROM is Philips, the company Philips product. So that's the reason why it is this sort of communication method. It's called I2C bus based communication method. I will introduce you more details about that when we involve in that test, I think, which is in lesson 10. Alright, pretty much that's the test.